Hey everybody, here we are again with yet another video in Joanne's amazing video series for Foundations Pre-Calculus Math 10. I don't know why I cannot say that. Anyway, this should, for me, finish up the chapter because I was doing them out of order. So I'm pretty excited, I'm pretty jazzed. And this stuff's, I like this because it's an application of what we've been doing. Pretty cool. So we are gonna look at cube and higher roots. The last video, video number 3, was just square roots. Okay, so surprise, we're going to tree out the numbers again. You should be so good at your multiplication table and have some of these figured out. 4 and 2, and 4 and 2, and 2 and 2, and 2, and 2 and 2, and 2. 2 and 32 would have worked, and then break down the 32. I've just done enough of these. I got a pretty good idea of where I can break them up to make the least number of steps. Oh, it's easy. 4 and 2, 2 and 2, and 2. And this one, okay, it ends in a 5, so I know 5 has to go in there. So 5 times 25, 5, and a 5, and a 5. Okay, ta-da! We've treed them out. Now we're going to do the cube root. Let me see if I can do it. Sorry, that went out of focus. Okay, so what I want you to notice is the teeny tiny 3 right there. That means cube root. So I'm going to. So when you're talking about exponents, to the power 3 is cube. So this is kind of the opposite. And before we go further, I will fess up. All of the square roots that we did before, we did like the square root of 16. Oops, move that back so you can actually see. And focus again. Sorry about that. Technically, sort of, maybe. They could have been written like that. So when you're doing a square root, there's a little 2, an understood 2. Just like when you do, like, let's say you write x. Well, there's an understood exponent of 1 there, and there's a big coefficient of 1 there. But that's what it always is, unless it's something else. Okay, that didn't make any sense. You just don't always write those. It's understood. Same thing here. Okay, anyway, getting back to the cube root of each of the numbers, what we do when we did square roots, we circled sets of 2. When we do cube roots, we circle sets of 3. So, dun, 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 dun. So if I do the cube root of 27, oh, the part I forgot to say is this is not the same. It has to be the teeny tiny 3 kind of on this little tail. So this is not root. That is actually 3 times the square root of 27. Don't stress. Just know it's got to be the teeny tiny 3. So the cube root of 27 is 3. Done. Just like when we did the square root, it was 1 from every number. Here it is 1 from every triple. Any triplet? However you want to talk about it. So what this means is if I go 3, where am I going to write it? I'm going to put it up. What's this? 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. So this is basically asking what number times itself 3 times over. So 3 times 3 times 3 gives me the 27. That's what a cube root is about. Just like a square root is what number times itself. So two numbers give me whatever number we're looking for. Trust me, clear as mud maybe at this point, we're okay. So we're doing the cube root of all of these. So we've got, there's a set of 3. There's a set of 3. So 2 times 2, and we get 4. 8's kind of boring. There's my set of 3. So the cube root of 8 is 2. You want to get really fancy. I don't know if it's going to help you, but imagine, if you will. Well, you're probably going to have to imagine that I can draw. Whoops. Oh. Okay. I didn't get hired for my skill for drawing. This line needs to go like that. Imagine if you had 8 little cubes and you wanted to make them into 8 teeny tiny cubes, and you want to make it into a bigger cube. Each side would be 2 by 2. I don't know if that helped. Okay, here we go. There's 3. It's 5. Bada boom, bada bing, we're done. And that's all there is to it for doing a cube root. Wait, there's more. We're going to skip down here because this is where the real power comes in, is we can use this to do whatever set of power the questions ask. So for example, see the teeny tiny 4? That means I'm doing the 4th root. So it's what number times itself 4 times gives me 81. I don't know. So 3 it out. 9 and 9, 3 and 3, and 3 and 3. So if we are doing the 4th root, we're going to circle sets of, 4. My answer is 3. Okay, and we can even do the 5th root of 1024. Okay, I'm going to cheat a little bit. I know it's an even number, and I know I can divide it by 2, but that's 512 and 250. It's just going to take me a long time. So I'm just going to say divide by 32. Uh-oh. Now that looked weird because I'm worried that I screwed up. 32 times 32. Okay, 1024. I don't trust myself. 32, 32. Again, a 2 and 512, and then bring down 2 and 256. That's spectacular. I'm just trying to be lazy. So it's 8 and 4. This is 8 and 4. I think you already know I'm just going to get a whole whack of 2s. 4 and 2. 2 and 2. 4 and 2. 2 and 2. 2 and 2, and bring this one down. Oh, bring those 2 down. That one splits. 2 and 2. Bring this guy down. This one down. And that one down. Now, no matter how you do it, you should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There should be 10 2s on your last line. But the question said, I need the 5th root. So why am I even telling you? You know. 1, 2, 3, 4, 5. Set of 5. 1, 2, 3, 4, 5. Set of 5. This is 2 times 2. And that is going to be 4. So again, what that means, if you go the reverse to check, that means if I go 4 to the 5th, which is 4 times 4 times 4 times 4 times 4. Wow! My brain's thinking the other way. I should get this number. And for those of you that are wondering why I went from putting dots here to suddenly putting multiplication. I don't know. It's the end of the day and I'm tired. Don't stress over it. In general, I don't like using the multiplication sign because we start to use variables and it's often X and it just gets confusing. So let's see if I can do this. 4 times 4 times, oh, my calculator is lovely. It's displaying it. So I've got 1, 2, 3, 4, and that one. Yay! Let me show you something a little more powerful. Oh, I don't know how well we can see it on this one. So I can go 4 and a bit closer so you can see better. Okay, or I should just get a newer calculator. There's a button here that says y to the x. And it's like this squared button that you can't really read anymore either. But it allows you to pick whatever exponent you want. So, whoops, too far. I can also go 4 to the 5th, and I can go 4, and then I hit this one is y to the x and 5. So I'm going to go y to the x. Oh, look at that. See that doodad there? That's called a caret. It is, I honestly think it's left over from computer science. It's how some calculators show exponents. So 5, and we get 1024. Okay, again, that doodad is a caret. And on some calculators, usually the ones that are Texas Instrument, which we usually just call TIs, they have a button that looks like this. Well, nice and even. And some calculators have a button that for some reason has X to the Y. Any one of these is a shortcut if you don't trust yourself to do that. Because, you know, I get busy and I forget. Did I hit that 4? Do I need one more? This is a faster way. So this is your exponent key. All right, coolio. All right, just about done. And also just kind of out of focus. Square root of 1. You know what? I'm going to use my calculator. Because if I start with 1 and I go to, I don't even know how you would do that. Like 1 times 1 prime factorization. So I'm just going to use my calculator. And on mine, my square root is dead. Oh, no. I have to go square root first and then 1. And ta-da, it's 1. And I'll just tell you, because like 1 times 1 is 1. And if I want the cube root, what number times itself 3 times is 1? It's 1. And if it's all 1 here and here and here. And that's just because 1 is, I don't know, today I'm going to call it magical. Tomorrow it might be witchcraft, but today it's magical. And you know what? If you take the square root of 0, all of this, there you go. If you want to know why, well, the square root is saying what number times itself gives me 0, and 0 times 0 is 0. Ta-da! Or the cube root, what number times itself 3 times is 0. 0 times 0 times 0. If that doesn't make you happy, Google it. I'm sure you can find some really great long explanations. But ta-da! Have a spectacular day. That is the end of this one. And for me, the completion of the entire first chapter of Math Foundations Pre-Calculus 10. Bye-bye.